Hello there, this is Kishore DS, and have taken up task number 6 in the GRIP internship program offered by the Sparks Foundation. So here in the task 6, I have done prediction using a decision tree algorithm on the dataset that they are provided called IRIS, which had a few parameters like sepal length, sepal width, and etc., which were oriented with flowers. So let us jump into it. So we are basically importing certain required libraries. So we are importing pandas. We are importing matplot live .pyplot, and we are importing numpy too. So numpy also, I mean numpy. So when we jump in, the first step. We are just loading the CSV file into a variable called data iris. So then we are just displaying the head of the data iris, which just displays the first 5 columns of the data set, so that we get a bit of clarity on what the data set is, and also a basic idea on how the data set parameters are. So then we are just displaying the tail too, so that we confirm is the data set in the same pattern throughout the end, so that the tail displays the last 5 columns. So we can just compare with the head and tail and verify that if the parameters are on the same pattern. So next we go to the data iris describe, which describes the various columns present in the data iris, that is the data set, and other oriented parameters like the count of data present, the mean of the data, the STD, minimum 25%. These are other oriented parameters that are related to the data description. So then we see the data iris dot shape, which displays the shape of the data, that is uh, the rows and columns present in the data. There are 150 rows and 6 columns present in the data. So then we go to the data iris dot drop id. Why we use the function drop? The drop function is going to drop a column. We are dropping id because when we display the head and tail, we found that the id is more or less related with the index of the data alone. So the id may not be that much essential for us, so we are dropping it as a process of cleaning the data set, so that we get less things to compute and analyze. So next we are coming to display the data iris dot head. Here we can evidentially see that id is missing, so as we drop the column. So next we see again I have displayed the shape, so that you get to know that the columns have reduced by 1. Before we had 6 columns, now we have 5 columns because we have removed the id. So this is number of unique parameters, that is number of unique values present in each parameter of the data set, each column of the data set. We have sepal length centimeter, sepal length to be 35 to contain 35 unique values, and the sepal width has 23 unique values, and so on. So next uh, we are checking if the data set contains any null values. So we found that it's absolutely clean and we have no null values, because these null values may result in errors and unwanted passing and analyzing of the data set. So we are removing the null values. So basically, since this has no null values, we are just proceeding with the same data set without any modification. So now I have I have imported a few other libraries too. I have imported these libraries in the subsequent chunks wherever it is needed. I have not made it to put up these import parameters into a single chunk. I am doing that at every consecutive chunk wherever it is needed. So I am importing cborn as SB, and I am using that cborn library to construct a heat map using the correlation of the data set. So this correlation is like we get the proportionality between each of the columns and parameters present within the data set, and this range of colors, the intensity of the colors denote the correlation between correlation, that is the interrelationship and the proportionality between the columns and parameters of the data set. So next I have displayed this count plot. So this count plot also serves a purpose here. I've displayed count plot for the species with respect to the species. So this what this count plot does is it tells a clear, it gives us a clarity on whether the data set is proper. Like there are possibilities that there is a great imbalance in the data set which may lead to a greater problem when we do the analysis. So we are checking if the data set is balanced, and if not, we will have to augment certain data to any of the parameters. So now we find the data set is almost perfectly balanced, and that each column, each species have their own set of counts and proper values. So next we move on to this. So as I said, I am importing things required at each chunk so that we get a better understanding. So here I have imported train test split from sklearn model, sklearn dot model selection. So here we are just assigning x, variable x with the data set's first four columns. That is, we have ignored the id, and all other columns except the species is just assigned to x, and the y is assigned with the species column, that is the last column of the data set. Now then we are using the train test split to assign training data and test data as per our requirement. Here I have given test size as 30, which splits up the training model as 70% of the data set, and the 30% of the data set is given to the test model. Okay, so the X train and Y train are trained with 70% of the data sets parameters, and the remaining the 30% of the data sets parameters goes to X test and Y test. So now we have imported tree from sklearn. So what we are doing here is we are assigning we are creating a model named dt, which is going to use decision tree classifier function to construct a decision tree based on the data set. So we are just assigning dt with 3 dot decision tree classifier function, and we have given max depth as 5 so that we get a graph with a tree with a depth of 5. So then we are just we are just fitting, that is we are inserting the training models, namely x train and y train, into the decision tree model. So that's it. That's about that. And then we are using a dt dot get parameters, that is params, so that we get all the things that are oriented, the features that are oriented with the decision dt model. So here we find that the criterion to be Guinea. So we have other criterions too. I have tried and found that Guinea is pretty giving me pretty much higher accuracy, so that I'm using Guinea over here. So we can also use various other criterion like entropy, but I found Guinea to be giving a perfect and I mean a higher accuracy. So then we are printing the DT score, that is the accuracy of the model being trained, and the DT score of test, that is the accuracy of the model being tested. So we get training to be 1 and testing to be 0.9777 and so on. So then again we are now we are importing metrics from sklearn. So now we are assigning the DT, that is the DT model dot predict of x test, the test parameter, to that pred. So with that we are what we are doing is the tendency, that is the accuracy with which the model is able to predict, like the x test, given the values of x test, how better it is predicting the y parameter, that is the y test, and we are calculating the accuracy score over here. So next we are moving on to the featuring. That the featuring, I'm assigning a variable called, I'm declaring a variable called featuring, and I'm assigning the data iris data sets columns from 0 to 4. We have removed, and hope you remember that we removed the index column, so we get the remaining 4 columns here. So I'll tell later on you'll know why this featuring is being declared. I'm just printing the featuring to ensure that the data set is correct, to check whether the insertion is, I mean the assignment is correct. So next, from 6 we are importing a string IO. These parameters will be used later on, like subsequently you'll see in this chunk we are using these things. And from sklearn tree, I have imported export graphics. This would help in displaying the graphics, creating a graphic tree. So and again I'm importing pi.plus. So dot data is assigned with string IO function, and export graph is we are using that, and we are including the parameters like the DT model, and out file is declared as dot data, that is string IO function. And then future names we are giving with featuring that we declared previously, as I said, that has the zeroth column to fourth column as the parameters. Then we are giving filled is equal to true and rounded is true. These things ensure integrity and proper display of the tree. So now we get assigned the final graph that is going to be displayed later on. So the final graph with pi dot plus, we're using the pi dot plus dot graph from dot data of dot data that is string of a function dot get value. So after that, from ipython.display, we are importing image to create a frame to display, like the image function, which assigns frame and displays the tree, the final tree that we are expecting. So we are calling the image function, and giving the parameters as final graph dot create png function is called, which creates a png image of the graph, that is the decision tree model, and which is created with the depth of 5, and you can see that here. So after that, I hope you remember that we checked the prediction accuracy previously. So we are going to check prediction accuracy and other oriented model along with that. Just we are going to ensure how check how the algorithm, that is the code that we have given, performs better. So now we are assigning a variable called express with uh, data DT model dot predict of x test, that we did already. You might remember that. So we are assigning that prediction of x test into this, and just we are printing that so that we can ensure it is assigned correctly. From there, from after that, from sklearn.metrics, we are importing classification report. There are various other parameters that can also be imported using sklearn.metrics, like precision, recall, FN score, accuracy. These parameters, despite these parameters are going to be displayed afterwards, we can also display them individually by importing them. So now after that, we are just using the classification report function with the express that we express that variable that we declared previously, along with y underscore test, that is we are just uh, seeing how best our algorithm is performing in terms of precision, recalling, and FN score, support, accuracy, macro average, weighted average, etc. So we find that the iris setosas, each species, we saw that there were three species, three unique values in the starting. These unique values, how much precision that the algorithm that we designed is giving, and the recall, F1 score, support. All these are parameters that are oriented with the accuracy and performance of the model. So we find that our accuracy to be 0.98, which is around 98, which means that the accuracy is around 98 percentage, which is really a great thing and highly appreciable. So our algorithm is working much better. So this is all about the task 6 that I have taken up. Hope you liked, understood, and enjoyed the video. Thank you.